Hello, this is Group 58. I'm Jeffrey Chang, and we're doing recitation O2.
I'm not really sure. There's not like discussion questions. So do we just talk about all the questions and the answers?
Yeah, I
think
guess
so,
so.
I think we just like compare answers, right?
Yeah.
Okay.
Yeah, compare answers, say if we agree or not. But yeah.
All right. Well, I guess we can just start with the very beginning. So I'm sure you guys are all familiar. We all did it. So stick contacts the puck when it arrives at position 3, which is here, for a very short period of time, 0.005 seconds. Use that fact and the figure and information to make a reasonable estimate of the components of force exerted on the puck by the stick while they are in contact. So I'll just go ahead and go first because I'm screen sharing. So basically, I use the momentum update principle, which is like the thing they've been teaching us in lecture all week. And I found the components of the force exerted to be -320, -640, and 0 newtons, respectively. And then I've got all the work right here. Basically, I found the average velocity because we know that it's spaced 0.1 seconds apart for each dot. So I found the average velocity from 2 to 3 seconds, and then, or from position 2 to position 3, and then the average velocity from 3 to 4. And then through that, I found the changes in momentum, and then I divided it by the change in time, which was 0.05 seconds. And that's how I found the components of force to be what they were. How about you guys?
Yeah. I pretty
Yeah,
much did
I
the
did the
exact
same
same thing.
Yeah.
Yeah.
I did the same
Okay.
thing for the first one, or like the X component, but for the Y component, I just saw that it travels double the distance in like the same amount of time. So I just doubled it.
Yeah, that makes sense too.
I mean,
So
honestly,
you're
aren't
working
all these
smarter,
numbers
not
like,
harder.
yeah, that's true.
So for the explanation of why my approximations and assumptions were reasonable, I said I assumed the net force was equal to the force applied by the hockey player because the puck is on ice, which is a relatively frictionless surface. Said I also assumed that the ice surface was flat and that there was no change in the z direction, so like up and down. Do you guys have anything else or just that?
No, that's about it.
Okay. And then how does the instantaneous velocity of the puck at position 3 prior to being struck compare to the average velocity of the puck in traveling from 2 to 4? I said the instantaneous velocity of the puck at position 3 is purely in the positive x direction, so it would have some component positive x 0 0, but the average velocity from position 2 to 4 has changed in position in both the positive x and negative y directions, so the velocity would have components positive x, negative y, and 0, which would make them different, obviously.
Yeah.
Pretty
Guys
much.
agree?
Yeah.
And then for problem 2, this one was a lot harder. But
Yeah.
I'll just let you guys.
It's not even like a homework
see
either.
what
Like the
I
homework
have.
was like completely different from what this was. I was like, I don't even
I know
understand
this was tough. So like, obviously the system is the ball, and their surroundings are the foot and the ground that act on the ball. You guys agree with that?
For sure.
And then for this one, I said the components of force exerted on the ball by the kick is approximately 602, 0 and 0 newtons. And so basically my explanation for this is that assuming that there's no drag force acting on the ball and it's traveling 5 meters per second in the negative y, and then we don't know how fast in the x, we know that if there was no drag on the ball, it would make it to here in 0.01 seconds. So that means it would also go to here if there was no drag. So the way I solved it is I said that I used like this coordinate and then 0 to find the change in momentum. And then I divided by the change in time, which was 0.005. And I got 602 because at first I did it from here, but then you got to remember that there's the drag force that's fighting the kick force. Does that make sense?
Yeah,
because
that makes sense.
kick force is going to the right, I assume, and then friction is going to the left. This opposing
Yeah,
force.
so like the kick force it says it's perfectly in the x direction. So we know that like there shouldn't be any change in the y velocity. So in theory, it would get to here and then to here on a frictionless surface. So that's why I
Yeah.
said that this is the power of the kick. But then to find the magnitude of the drag force, I didn't really have a good plan. I guess it would be like from here, which is where the ball should be, to here. But I don't know how to convert that like distance to force.
Yeah, that
Do you guys have an answer for that?
I did not.
I'm not really sure, but would you just like I don't really know. Would you take like the components of the one without friction and then subtract it by the one with friction and then just take the magnitude of that? Maybe. I'm not really sure.
Well, yeah, that could work. I did find,
Yeah.
I found the force like originally, like when I did it from this point to the ball to be 430 newtons. So are you saying that the magnitude of the drag is just 602 minus 430?
Maybe. I'm not really sure.
But then it would also have like a y component,
Yeah.
which is what's weird. So I'm not really sure. Do we
We
want
could
to
just
say
try. I mean, it's better than
Okay.
not having a zero answer, I guess.
All right, so I'll say it's 602 minus 430, which would be what, like 128?
Wait, I'm so
Or
sorry.
what
Wait,
would
what
it
was
be?
it? Wait, what was it? What was it? Wait, what was it? 602 minus what?
It's
172.
172.
602 minus
Yeah.
430.
Yeah.
It would be 172.
172. Yeah.
And then in the y direction, it would just be, well, I think I got it originally to be negative 302. But that was when I read it wrong for the,
But like, isn't the force acting in the opposite direction? So shouldn't it be negative?
yeah, so it would be acting like this way, which means it would
Yeah.
have an x, it would have an x, like a negative x and a y component. Does that make sense?
The
So I
y
guess this
should
would
be
technically
the
be
y
like
should be
negative.
positive. The negative it should be net. Wait, but let's.
Right.
But
Yeah.
technically the graph
Yeah.
is going down this way. Isn't that already a negative graph? So technically, wouldn't it be positive?
Well,
Because
the
right now it's
x
in
would be
quadrant 4,
negative
right?
because it's fighting it like to the left, but the y would be positive.
But right now the graph is showing quadrant 4, which is positive x, negative
Yeah,
y.
I know.
Yeah.
But when you talk about like, so like this, the ball is moving positive x, negative y, but the
Uh-huh.
drag force would be the opposite of that.
Opposite. Yeah. Oh, okay. Yeah.
So it would be negative x, positive y.
Mhm.
So I guess we'll say the negative x direction, it was negative 172. And then in the y direction, I mean, we can just do it real fast. It would be 5 meters per second. Yeah, hold on. I can work this out.
Wait, so for that one, I'm gonna post the YouTube link right now, and then everyone can just say that I have participated. Yada yada yada.
Okay. So you mean say it like in the discussion board or say it now?
Yeah, on the discussion board, because for you to access the discussion board, you had to comment something.
Okay.
Kind of, yeah. Do I have to say the statement? I assume I have to say the statement too.
I think maybe the Y direction would be 64, but that's kind of like a big guess.
I don't know how we would. This was a weird one. I guess
was
it's better
hard.
than no answer.
I mean, if you guys think you know how to do it, I'm all ears, but I honestly don't. Like, I think Tyler's reasoning was good, like finding the difference. But as
That
far
makes
as in the
sense.
Y direction, like that's hard to do. Like it should go 5, but it only goes this far. So what does that mean?
Um,
So I just found like the difference in momentums. Like if it really went 5, then it would be 2.15 kilogram meters per second. But since it went like 3.5, it was only 1.51 kilogram meters per second. And then the change in time would make it 64 newtons.
that sounds right enough.
Yeah, I
but
mean, that's like
then-
the only way I can see that you can solve it with
Yeah, I-
given the variables they give you, the given
Yeah,
I couldn't
information.
Yeah.
think of any other way to come up with an answer.
but then to find the
But-
magnitude, don't you gotta do like the square root x squared plus y squared thing?
Oh yeah, I guess you're right.
Yeah.
I can do that real
So
quick. Okay.
yes, yeah.
Okay.
Magnitude is 183 newtons.
Let me check this.
183.5. Is that what we're going with?
Yeah.
In the direction opposite of the ball's motion. How's that look?
That actually looks
Yeah,
pretty
that's
good.
Yeah.
Okay. So everybody good with me turning this in?
Yep. Sounds good to
Indeed.
me.
All right. I will try and share that lab document so you guys can put your stuff in there. And then Jeffrey, if you just want to send me the YouTube links again, I can put them on the discussion
Oh,
board or
no,
whatnot.
it's fine. I got it. I can do it. I'll just tell you.
Oh, you
I'll
put
just,
it.
I already did the lab one. So all you guys have to do is just copy paste. I have participated in the discussion in the video, yada yada yada, for lab one,
Okay.
and then after I post the video for recitation and lab 2, then you guys have to state the same statement.
Okay. That
Do
sounds
we have to do
good.
that for lab